In this lesson, we're going to look at some of the ways that you will be required to use a calculator on the AP exam. So I just want to go over a few of the basic, some of the setup on the AP exam of the types of questions you'll see and how many of each. So there's two major portions to the AP exam. They count 50-50 in terms of your score. The multiple choice has two parts, a 30-question no calculator part where you get 60 minutes, okay, a 15-question part where you can use your calculator and you get 45 minutes. You get more time per question, so that should be an indicator that these questions are typically more difficult. On the free response, the first two free response questions, you get to use your calculator, you get 30 minutes, and then the last four free response questions are no calculator and you get 60 minutes. So according to the course description from the College Board, the graphing calculators that you use on the AP exam are expected to be able to do the following things. Plot a graph. Okay, so you should be able to graph a function. You should be able to find the zeros of a function. Now they say find the zeros of a function, but we're going to use that feature to solve equations. That's the number one thing we use this for, solve equations, and that's what we're going to work on today. You should also be able to numerically calculate the derivative of a function. Okay, we'll talk about that one. They don't use that one as often as number two. And then numerically calculate a definite integral, but we don't know how to do those yet. So the first three are what we're focusing on. Okay, now, if an answer is given as a decimal approximation on the free response portion of the exam, it must be correct to 3 places after the decimal. If you only give 2 places after the decimal, then they'll count that as incorrect. Okay, or if the first 2 numbers after the decimal are correct and the third one's wrong because you rounded in the middle of the problem, you'll get that incorrect. Okay, so we'll talk about that on the next slide, but from here on out, anytime you have a calculator for a quiz or a test, I'm expecting that your answer is accurate to 3 places after the decimal point. Okay, the other thing you need to realize is that your calculator should always be in radian mode. Unless you're in physics, put it in radian mode today and never change it. Those of you in physics have to remember to change it back and forth because I know you use degree mode in physics but radian mode in calculus. Alright, so first thing that we're going to look at is just giving a correct answer from your calculator. Okay, so before we do anything else today, go to your calculator, hit the mode button, okay, and make sure your calculator is in radian mode. And like I said, unless you're in physics, you'll leave it in radian mode for the remainder of the year. Okay, now imagine that you type in something like 3 divided by 13, and you have to report that as your answer, okay, on a free response question. Okay, and so this is what the calculator gives you. You have 2 options for how you give your answer. Okay, we have to go 3 places after the decimal. You can round. Okay, so if we round, the 4th number is a 7, and so that means increase this one here. And if we round, our answer would be 0.231, and that would be correct. Okay, but you're also allowed to truncate. Truncate means that all you have to do is look at the first 3 numbers after the decimal and ignore everything else. So just read the first 3, forget everything that comes after it, okay, and the truncated answer would be 0.230. This one has far less chance for error, and that's the one I recommend. Okay, so truncate means just write down the first 3 numbers after the decimal. Don't worry about rounding. If you round, it's okay. It'll be counted as correct, but you don't have to. Okay, you can truncate. Alright, so the first thing we're going to do is just look at solving an equation with your calculator. Hopefully you already know how to do this, that maybe you did this in Algebra 2 and Pre-Cal. Okay, so the first one we're going to do as an example is this equation up here, and we're going to solve for x. Obviously, this is something you can't do without a calculator. Okay, and so the first way we're going to look at to do this with a calculator is to go to y equals on your calculator. And you're going to type the left side up here in y1, and you're going to take the right side of the equation and put it in y2. Pause the video if you need to. I'm just going to keep on going for those people who know what they're doing. Okay, the second step is we might go over and look at the graph. Okay, so if we're trying to see where the square root of x sine x is equal to the natural log of x minus 2 plus 2, where these things are equal, we're trying to find the x value that makes these two things have the same y coordinate. Okay, and so we're looking for the x coordinate right here where they intersect. Okay, let me caution you. Do not at any time during the entire year on the AP exam, any quiz or test, homework, anything, do not use the trace function. The trace function is not accurate. It will not be accurate to 3 places after the decimal. You will not get the correct answer. Okay, so we want to know exactly where these things intersect. Okay, so we're going to go to the calculate menu. Okay, so on your calculator, the calculate menu is right up here. It's second trace. Okay, up here, up at the top. And under the calculate menu, you're going to choose option 5 for intersect. Okay, now when you go, after you hit number 5 for intersect, it's going to take you back to the graph screen, and it's going to ask you some questions. First curve, well, the first curve we're interested in is the one in y1. Second curve, y2. If you only have 2 equations graphed, you just hit enter and enter. And then the third question it's going to ask you is guess. We've already talked about this. It doesn't mean guess. It means if these things intersect, these graphs happen to intersect more than once, then you need to tell the calculator which one you want, so get close to one or the other. Now if you look at ours only intersects at one point, and so you can, when it says guess, you can just hit enter. Okay, and you should get this answer right down here. Okay, since if this were a calculator question and you can use your calculator to solve an equation, underneath the equation that you're trying to solve, you just write the answer. You don't have to show any work because it's a calculator question. And so our answer would be 2.389. We're going to go to the third place after the decimal, and we're going to truncate. So 2.389, and that's how you'd write your answer. If you write 2.38, it's wrong. If you write 2.39, it's wrong. If you write 2.4, it's wrong. Okay, you have to be accurate to 3 places after the decimal. Now there is another way you can solve equations with your calculator. I'm going to do this one quickly. Some people prefer this method. I like the other one better. Okay, you could take this whole equation and you can set it equal to 0. So I can move all of this stuff over here on the right over to the left so that I have the square root of x sine x minus the natural log of x minus 2 minus 2. And if I have everything over on the left side so that it's minus this equals 0, now I'm going to be trying to calculate the zeros. The graph looks totally different. It's a different equation. I'd be trying to calculate where this thing equals 0. I'd still go to the calculate menu, so I'm still going to hit second trace up here to go to the calculate menu. Only now I'm going to calculate 0. Calculate the 0. It's going to ask me for left bound and right bound. So on the left bound, I go a little bit to the left of the x-intercept. For right bound, I go a little bit to the right of the x-intercept. Okay, and then we just hit enter and we get the answer. Okay, you get the exact same answer this way, 2.389. Like I said, I prefer the first one, less chance for error, because I'm not trying to do any algebra, but this way works as well. Okay, the other thing you have to be able to do in your calculator is find the derivative of a function at a point. Okay, and we talked about this already as well. Okay, so we're going to look at this one. The function is the cosine of x to the x. Okay, you might think you know how to take the derivative of this, but x to the x is not an exponential function. It's not a polynomial, and so none of the rules that we've learned so far actually apply to x to the x. So we have to use a calculator to find the derivative of this at pi. Okay, so on the calculator, we're going to hit the math button. Okay, and under the math button, you're going to look for the option and derive. For most of you, I believe it's option number 8. It stands for numeric derivative. Okay, and so most of you who have newer calculators, an 84 or newer, okay, you're going to get a screen that looks something like this, and you're just going to type in the x down here, take the derivative with respect to x, you're going to type the function in here, and you're going to say x equals pi over here. So that will take the derivative of this function at pi, and this is the answer you get. If you have one of the older calculators, an 83, you have to type in the same things, but you have to know where to type them in, and it's a different order. Okay, you type the function in first, then you have to type a comma, then you type x. This x right here is the same as the x they had to type right there. Okay, and then you type comma again and pi. Comma is right here above the 7. Okay, and no matter which calculator we use, we get the same answer. Okay, we would give our answer accurate to 3 places after the decimal and it would be 73.806. Okay, there is another way to do it. This one comes in handy if you had to graph this function for another question. Let's say we had to graph this for some reason. Okay, we already have it in y1, and now we want to find the derivative of this function at pi. And it's already typed in over here. Okay, so if I go to the graph, here's the graph of this function. Now if I go back to where I was before and I hit second calc again, there's another option down here for dy dx. So under second calc, option number 6 says find the derivative. Okay, it's going to, as soon as you hit number 6, it's going to take you over to this screen here, and it's going to ask you at what value do you want to find the derivative. You type in pi, you hit enter, and it tells you that the derivative at pi is 73.806. Okay, again, I would only do this method if you already had the function in y1 because you had to graph it for something else. Okay, if all you were asked was to find the derivative of this at pi, I would just do math 8 and do it that way. All right, let's try some free response questions. Okay, so what I'd like you to do is hit pause right now and see if you can try to work this out. And then when you think you have an answer, come back in. I'm going to work it out. Okay, if you were stuck and you needed a hint and you want to listen to the solution, I'll give you the first part. For this one, the function is f of x equals 2e to the 4x squared, and we're trying to find what value of x gives us the slope, a slope equal to 3. So what we're trying to figure out here is when does the derivative equal 3? Now some of you may have said, oh look, slope, function, 3, and you might have done math 8 and derive at 3, but you wouldn't get the right answer if you do that. Okay, because if you did that, what you found was the derivative at 3. It doesn't say find the derivative at 3. It says for what value of x is the derivative 3? Is the slope equal to 3? So you actually have to do a little bit of work by hand here. First you have to find the derivative of the function. So the derivative of this function is 2e to the 4x squared times 8x. And then we want to know where does the derivative equal 3. So we want to know where does this thing right here equal 3. So we're not using math 8. We're just trying to solve an equation. I need to know where does this equal 3. So I go to y equals. I put the left side of the equation in y1. I put the right side in y2. And I figure out where they intersect. Okay, so again, you have to know how to set this thing up. You have to know what the question's asking. It's saying where does the derivative equal 3. You also have to be able to find the derivative of this and set it equal to 3 so that you have an equation to solve. Okay, then you use second calc intersect, and you should get this answer right down here. 0.1675. So that's going to be answer A, 0.168. All right, here's another one to try. Go ahead and pause the video and try it, and then when you're ready, come back and I'll work it out. Okay, for this one, we want to know where do the graphs of f and g have parallel tangent lines. Well, if the tangent lines are parallel, that means that they have the same slope. And the way you find the slope of the tangent line is to take the derivative. So this question is asking, where does the derivative of f equal the derivative of g? Where is the slope of the tangent line for f equal to the slope of the tangent line for g? So again, you have to do a little bit of work by hand here. You have to take the derivative of f. The derivative of f is 3e to the 2x times 2. The derivative of g is 18x squared. And you want to know where these two things are equal. So again, you're solving an equation. If you can't tell already, this is a really important skill, being able to solve an equation with your calculator. So I'm going to do it the same way as the last one. I'm going to put the left side in y1, the right side in y2, second calc intersect, and it looks like these two equations intersect at negative 0.3906 or negative 0.391. And so it looks like the answer is C. Okay, here's one more. Go ahead and one more time pause it and see if you can work this out. Okay, for this one we're going to try and find the equation of the tangent line at the point where the derivative is 1. Okay, so derivative is 1, so we're going to need the derivative of this. The derivative of this is 4x cubed plus 4x, and we want to know where does the derivative equal 1. Again, it's not saying what's the derivative at 1. If it wanted the derivative at 1, then we just do math 8, or just plug 1 in right over here. It's saying where does the derivative equal 1. Okay, so again, guess what? We're solving an equation. Put the left side in y1, the right side in y2, and see where they intersect. Okay, so it looks like they intersect at this point right here. Okay, so let's see what we have so far. We have the derivative. We already know what the derivative is. Look, the derivative at this point is 1. So we already know the slope of the tangent line is 1. And by the way, if you realize that the slope of the tangent line that we're writing an equation for right now is equal to 1, and you look at these choices, you should realize that there's no way it could be a, because the slope of a is 8. Okay, and so we have the x-coordinate. We have an x-coordinate of 0.2367329, okay, but we need the y-coordinate over here. Okay, so we've talked about storing numbers. Let's go ahead and do, use this one as an example for storing numbers. Okay, I've got it up on the screen over here. Okay, I just found where these intersect. You should be in the same place maybe on your calculator. And I want to store this number so that I don't use a rounded number in the middle of the problem. For multiple choice, it's not going to create a problem. I'll find the right answer no matter what. But I might be a little bit off if I were to try to do this on a free response. So we want to store the answer. So I'm on the graph screen. I'm going to hit second quit. And I'm going to hit X right here, X. I'm going to hit the store button, and I'm going to call this A, so I'm going to hit alpha A. And it's going to take that X coordinate for the intersection, the 0.2367, whatever, and it's going to store it as A. I need to plug that number A into the function to find the Y coordinate. So now all I have to do is alpha A to the 4th. I'm plugging this into the function. Okay, plus 2 times alpha A squared. And when I plug it in, I get 0.11522. Okay, so let's see what we've got here. So far I know that the y coordinate is 0.1152. I'm going to go a little bit past the 3 places because I don't want to round too much in the middle of the problem. If this were free response, I'd be using all the numbers in my calculator. Okay, I would not be rounding anything. Okay, I already know the slope is 1. I already know the x-coordinate is about 0.2367. Okay, I need to get this in slope-intercept form because that's what their answers look like. So let's see what we get here. This is going to be 1x. This is going to be, I need negative, and look, you could do this too. I need negative this number right here, 0.2367 plus, and then I want to add this number right here. Okay, so it looks like it is 1x minus 0.1215. Okay, let's see. Can we find the right answer? Yep, right there it is. It's D.